In this video, I will go over a copy of the midterm preparation quiz to help you get ready for your midterm exam. Just as a reminder, the first question on the actual midterm will be exactly the question you see here and will contain some formulas. So you want to take a look at this midterm prep quiz so you have an idea of how the formulas will be presented. You can always come back to question 1 during the midterm if you need to use one of these formulas. So let's go ahead and get started. So the first section we covered were all the numeration systems. So let's take a look at these questions. Fill in the blank with the appropriate phrase. A number is a quantity and it answers the question of what? And I'm going to go ahead and use my pen here, and it answers the question of how many? Using the table, write the given Hindu-Arabic numeral as an Egyptian numeral, and we want to write 3,143. So we see 3 in the thousands position, so I want to have 3 of these pointing fingers. And if we look at our answers, it looks like, no, I'm sorry, not those. I'm sorry, the astonished person. My apologies, astonished person. And the only one that has those is right here. And let's just check and make sure the rest of it's right. 100, which is the scroll, 40, which are the heels, and then 3 staffs. So that's the correct answer. Write this Hindu-Arabic numeral, write the Hindu-Arabic numeral for the following Roman numeral system. So if you take a look at this, we have an M, which is 1,000. So we're going to have a 1,000. And then we have a D, which is 500. And then we have 3 C's, which are each worth 100, but we're going to add that to the 500. So actually, this should be an 8 here. Sorry about that. It should be an 8. Let me get back to my eraser here. Let's fix that up. Oh. Okay, let's try again. So that should be an 8. 1,800. And then we've got an L, which is worth 50. And then next to that is an X for 10, which is 60. And then we have IV, which is 4, so it's 1864. Using the table, write the given Hindu-Arabic numeral as a Roman numeral. Okay, so we have 2,000, so we know that 1,000 is an M, so I know I need 2 M's, M and M. And then I have a 7, which I can write as 500 plus 200. So I'm going to put a D and then 2 C's. And then I need 900, and I can write 900. Instead of writing it, I'm going to make a little shorthand here. I'm going to take 100 and subtract 10. So I'm going to write this as XC to get 90. And then I've got 6, which is V and I. Okay, write 43 as a traditional Chinese numeral. And we've got the Chinese symbols down here. Remember, we write these vertically. And remember, we're going to write a symbol over the power of 10 that we multiply by. So we have a 40 here. So we need to have a symbol for 40, for 4 first, which is right here. And we want to go over, I'm sorry, I'm looking at the wrong symbols. Here's for 4 here, and we want that over the symbol for 10, which is right here. So if I look across here, it looks like D looks like the correct answer. So it's got the 4 over the 10. 4 times 10 is 40. And then we want a 3, and that's the symbol. I'm sorry, that's not correct. Didn't look right. Let's go back. Let's try this again. Get my pen going again. So we want the 4, which is here, over the 10, 40, and then 43. I had them in the wrong order. 43, there we go. And now we want to do the Ionic Greeks, and we want to translate the given numeral here into our system. So we see this little V here, which looks like a 400. So I've got 400. And then I've got an epsilon, which is worth 60. So I've got 60. And then I've got a beta, which is worth 2. So this is 462. It is believed that the Mayans used 18 times 20 instead of 20 squared, so their numeration system would conform to their what, which had 360 days, and that was their calendar. Write the expanded notation for 692. So it's going to be 6 times 100 plus 9 times 10 plus 2 times 1. Write the Babylonian numeral as a Hindu-Arabic. Okay, so for this one, I have a detailed solution, and I have this also posted for you. Some of these take a little bit more work. So we see 2 groupings here. And we know that the symbols here, this is the symbol for 10, and this is a symbol for 1, and they're in two groups. And we know that the positional values in the Babylonian system are 3600, 60, and 1. So I've got 60s here, and I've got 1s here. So I've got 10, and so I've got, 3. The values here are worth, this is worth 60, and the value of the symbol shown there is 3 times 10, or 30, so 30 times 60 for this portion here, plus 3, so I've got 1803, which is answer B. Okay, and I might have the next one here as detail. Yes, I do. Okay, write the numeral as a Babylonian. So 246. So when we go from our system to the next system, to the other system, we want to think of the positional values, and we're going to start dividing. And we're going to divide by the positional value that's largest but less than the number that we're trying to convert. So the positional values, again, the Babylonian, are shown here. So we're going to take 246 and we're going to divide by 60. And we get 4 with a remainder of 6. So we need to have the left grouping to have 4 symbols for 1, and the right grouping to have 6 symbols for 1. And we see that answer there with choice C. And 12, now we're into the Mayan system, and we want to transfer, we want to take from the Mayan system to our system, and remember this is also vertical like the Chinese system, and the values here, the positional values are 7200, 360, 20, and 1, and we have 4 groupings here. So we have 4 groupings. The top value, if we look on our table here, is worth 11. And that's going to be worth 7,200. So we're going to have 11 times 7,200 for the top position. And then the next position is actually a 0. And then the next position, this is worth 8. And that value of that position is 20. So we have 8 times 20. And then finally, in the last position, we have a value of 18 times 1. We're going to go ahead and multiply that out, add them all up, and we get 79,378, which is choice C. And then let's go the other way. We want to go from our system to the Mayan system. Remember the positional values. The largest positional value less than our number we're trying to convert is 3,600. So I'm going to take 3,750 and divide by 360. I get 10 remainder 150. I'm going to take 150, divide by 20. I get 7 remainder 10. And then 10 divided by 1, of course, is 10. So I'm going to have 3 groupings. The top symbol must be a 10. Here's my 10. And then I have a 7, and then I have a 10, and I see this in answer D. And that was number 13. Okay, let's go back over here, pick up number 14. In the numeral 973, subscript 4, the 4 is called what? The 4 is the base. Okay, and looks like I lost my other detailed solution. Let's get those back up. Okay, there we go. All right. And let's see, here's number 15. Convert the given numeral to a numeral in base 10. So we have 142 and it's in base 6. So when we're going from another base back to base 10, all we do is write in an expanded form. So I've got the positional values here are 1, 6, and 6 squared. I've got a 1 in the 6 squared position, so I've got 1 times 6 squared, plus 4 times 6, plus 2 times 1. So 36 plus 24 plus 2 gives me an answer of 62. I'll get my pen back again. So that answer is going to be 62. And then number 16, we want to convert 130. Now we want to go the other way. We want to go from our base 10 system to base 6. So again, we're going to look at the positional values and we're going to divide 130 by the largest positional value less than 130, which is 36. So we take 130 and divide by 36 and we get 3, remainder 22. We take 22 and divide by 6, we get 3, remainder 4, and then 4 divided by 1 gives us a 4. So our answer is 334, base 6. Okay, let's go back to number 17. In the medieval times, people refer to the golden proportion as the, and what's the answer to that one going to be? And it is referred to it as the divine proportion. Determine whether the sequence is Fibonacci type, and if it is, then we want to identify the next 2 terms. So remember the sequence pattern for a Fibonacci. You add the two terms together to get the next term. So 4 pi plus 11 pi gives me 15 pi. 11 plus 15 gives me 26. So it is a Fibonacci type of sequence. So I'm going to go ahead and I'm going to take 41 plus 67, and I get 108 pi. And then I'm going to take 108, and I'm going to add that to 67, and I get 175 pi. So sometimes they're not all just numbers. Identify which of the following is the golden ratio. So which of these is the golden ratio? And I'll leave you to figure that one out. You should know that one. To determine the value that 47 is congruent to in modulo 7 system, what do we do? What do we do here? We divide by 47 and we get what? The remainder, because the remainder is how we figure out the congruence. All right, number 21. So let's go back to our detailed solutions here. So assuming that Sunday is represented by day 0, Monday by day 1, and so forth, today is Tuesday, determine the day of the week will be at the end of 11 days. So we're going to take 11 and divide by 7, and we get one remainder, 4. So we're going to move ahead 4 days, and it will be Saturday. And let's go back over to this one here. Now this one's pretty easy. If September is your starting month, what month will it be 20 years from September? You don't have to do any calculations on that one. It's still going to be September. Oh, let's go back to 23. Find the modulo class to which the number belongs for the given system. So we're going to take 22 and divide by 9. We get 2 with a remainder of 4, so it belongs to the 4, class 4. That was 23. Let's see, 23, 24. Okay, to change a decimal number to a percent, multiply the decimal number by, and then add a percent sign until you multiply it by 100. Use the circle graph to answer the question. A library classifies DVDs, and I have a detailed solution for this one over here. So we want to find the number of romance DVDs. So we have the total here, which is 1697, and we have the percent for romance, which is 14%. So I'm going to change the percent to a decimal, and I'm going to multiply that by the 1697 rather, and I get 237.58, which rounds up to 238. All right, and that was number. Okay, so we're going to stay over here for the next one, 26. Of 30 students in a math class attended class Monday. On Tuesday, only 22 students attended. What was the percent decrease? Okay, percent change, amount in the latest period minus the amount in the previous period divided by the amount in the previous period times 100. So we're going to take 22 minus 30, divide by 30, multiply that by 100. So negative 8 over 30 times 100. And we get a change of negative 26.67, which rounds to negative 26.7, or a decrease of 26.7%. And if a partial payment is made on a loan, interest is computed on the principal from the first day of the loan until the date of the partial payment. And what do we know this rule as? And that is called the United States. Okay, some simple interest problems. And for some reason, I keep losing that detailed solution one. Let's go back over here. There it is. Okay, and so we're down here to number 28. There we go. Determine the simple interest. So I equals PRT. So they told us the principal 522.26. Interest rate is a decimal 0.055, 91 days, and they tell us to assume 360 days in a year. And if I multiply that out, I get $7.26. And next problem is another simple interest problem. And this time they want us to find the interest rate. They've given us the principal, the interest, and the time, and they want us to find the rate. So we're going to use the same formula, but this time we're solving for the interest rate. So I put in the values I was given. I simplify on the right-hand side, 4184 times 237 divide by 360, and I get this value here. I'm going to divide both sides by that value, and I come up with an interest rate of 3.5%. Okay, now we're going to determine the date of a loan. So we took a loan on April 10th for 120 days. And I don't have the table here, but you do have the table in the test, and I'll show you over here. So we started on April 10th. So if I go down here for April 10th, which is day 100, and I'm going to add 120 days, so that's going to take me to 220. And so it's going to be due on August 8th. So those are pretty straightforward questions. They're not too difficult. Okay, and then let's go back over here. So Chris owns a lawn service. To pay for startup, he borrowed $26,000 for 7% for 1 year. Find the interest. Simple interest again. We're still on simple interest. So 26,000 times 0.07 times 1 year, so $1,820. Okay, let's go back over here. An investment is the use of money or capital for income or profit. Okay, another interest question over here. So now we're doing compound interest. Now we have a slightly different formula. And again, all these formulas are in question 1. So here's the compound interest formula. Principal 1,400, interest rate 0.06, 4 years, compounded quarterly. I drop my values into my formula, go ahead and simplify, and I come out with 1776.58, which is answer C. And I'll let you check those calculations. And that was 33, 34. Determine the effective annual yield for $1 invested for 1 year at 4.5% compounded quarterly. So again, there's the APY formula. I put in my values, I do my calculations, and I come up with, and remember, this is always going to be larger than the number that you started with. So actually, of all the answers here, the only one that makes sense is C. Adam wishes to have $20,000, so this is a present value formula, in 18 years to buy a new car. How much does he have to invest in a CD paying 1.29% compounded monthly? So again, I use the present value formula shown here, put my values in. Here's all my steps here, and there's my final value of $14,159.82. The true rate of interest charged for a loan is called what? What's the true rate of interest charged for a loan? And that's called the annual percentage rate. And then let's go back over here. Now we're going to do an installment loan payment. And they've given us the formula, and they're going to finance $62,000, 6.5% monthly payments for 3 years. So again, here's my payment formula, my monthly payment formula, put my values in. Remember the negative exponent, very important here in the denominator. And when I get finished, I come down here to $1,900.24, which is answer A. Meredith needs a new roof on her house. The cash cost is $2,800. She decides to finance by putting 25% down. Balance is 36 monthly payments of $66.78. What is the finance charge she will pay? Okay, so how much did she actually finance? She didn't finance the whole amount because she put 25% down. So she actually financed $2,100. Then if I take her 36 payments and multiply that out times the amount of each payment, the total she paid was here, $2,404.08. And if I take the difference between that and the amount financed, I get the finance charge of $304.08. Okay, Jack wants to purchase a used car that has a cash payment of $12,000. The installments include a down payment of $3,000 and 48 monthly payments of $218. What's the finance charge? So just like the prior problem, we figure out what he actually financed, which is $9,000, figure out the total of his payments. The difference between those two is the interest paid, $1,464. Now for the second part of the problem, to find the APR, take the finance charge, divide by the amount financed, and multiply by 100, and then take that value and look in the table for the number of year payments he's doing, and he's doing 48 payments, so down here, last row, and you look at the value that's closest to that, and the value that's closest is in the column labeled 7.5%, so that's his interest rate. Okay, so an outstanding credit card company determines a cardholder's minimum payment by adding all new interest to 1.5% of the outstanding balance. And there's the interest rate. On November 1st, a customer used his card to buy the following items. Using the information below, we want to find out first what the minimum payment is on December 1st. And remember, the minimum payment the card said was 1.5%. So the first thing we need to do is add up all of his charges during November. was $11.87. So he's got to pay 1.5% of that, which is $17.805, which is going to round up to $18. Now, on December 1st, the customer pays $300 rather than the minimum. So now he owes, or she owes, $18.87. So on January 1st, first thing you have to do is pay the minimum, 1.5% of that. And then you also have to pay interest on that balance for 31 days in December, which comes out to down here. Add the minimum, the 1.5% plus the interest, you get $2830.387, which rounds up to $29. This is a problem that should have been a little earlier and somehow got out of sequence in my copy of the prep quiz, but this is a percent change question again. Population of a country has been increasing for several decades. In 1990, the population was 232 million. In 2014, it's 279 million. Determine the percent increase. So we're going to take the 279 minus the 232, divide by 232, multiply by 100, and we've got an increase of about 20.3%. Okay, so where are we at here? Okay, fill in the blank. A buyer's gross monthly income minus any fixed payments with more than 10 months remaining is known as the buyer's what? That's the adjusted monthly income. Okay, so this one we're going to figure out the payment for I think I have a detailed solution for number 43, yes. 25-year loan, $95,500 with an interest rate of 5%. And this table shows you the principal and interest per $1,000 of mortgage. Okay, so for a 25-year loan at 5%, 25 years, the value from the table is right here, 5.84590. So we take the amount of the mortgage and divide by 1,000, we get 95.5. So we're going to take 95.5 multiplied by the value from the table, and we get a monthly payment of $558.28. And so the correct answer for this one is D. The Morgans are buying a house for $715,000. The bank requires a down payment of 20%. How much is that down payment? So you're going to take 20% of $715,000, which is $143,000. Sandra's buying a house for $80,000. The bank requires 3 points. Calculate the cost of the points. So you're going to take 3%. And we're going to assume this is the amount of her mortgage, so it's going to be $2,400. And let's go back over here and see if there's some definition questions here. Yeah. An account into or out of which a sequence of scheduled payments is made is called what? It's called an annuity. And then we're almost to the end here. Use the ordinary annuity formula to determine the accumulated amount in the annuity. Record to the nearest cent. So $1,000 for 12 years at 6% compounded annually. So here's my annuity formula. I put my values in, went ahead and simplified, and I came out with this amount. And it's $1,686.99. So not a whole lot is going to accumulate there. And another annuity problem. And here we want to figure out if we put in $10 semi-annually for 10 years at 3.5% compounded semi-annual, which means twice a year. Here's my calculations here, and I get $237.02. Not a whole lot. Again, we're only putting $10 in. To start a new business, Eric invests $765.13 each month in an annuity paying 12% compounded monthly. Find the amount in the annuity after 3 years. So again, here's my formula here, here's my calculations, and he's going to have almost $33,000. The correct answer here is A. And I think there's one more. Yes, sinking fund problem. So sinking fund is how much do we have to put in now in order to accumulate a certain amount. So we want to accumulate $29,000 after 8 years, semi-annual, 8%. So here's my formula. I put my values in, and so my payments are going to be $1328.78. So hopefully this review will help you get ready for your proctored midterm.